Alright mate, welcome to video number 37. This video is on recurring decimals to exact fractions. And I've already done a recurring decimals video, but that was for the top end of foundation. This is the higher stuff, alright? Please watch that video first if you feel like you're not understanding some of the stuff that's going on in this video, and it might help you. Okay, and I've explained the two keywords in that particular video as well, so I won't go into that here. The method is as follows. Make the recurring decimal equal to an x. This is sort of an algebra thing to do, but I think this topic is still very, very much number related. You're manipulating numbers more than you're doing anything with algebra, just making it equal to a letter. So multiply by a power of 10 to remove the non-repeating part past the decimal. Do the same thing to x again if you need to. Sometimes you don't, but that is for the trickier ones. But use a different power of 10, obviously. And try and use the smallest one that you could possibly use after the one you've already used. Then you subtract to get rid of the repeating chunk of numbers, and then you divide to leave x equal to a fraction. We've got to then simplify that fraction if it is possible to. All right, now I'm going to go through question number 1, the three things in question number 1. Question number 1a is 0.2 non-recurring. You could put 29 over 99, like I said in the last video about recurring decimals, but I'm going to show you how it works using this method, because sometimes you do have to show how you get a particular fraction. They'll give you the answer of 29 over 99. How did you get there? You have to show it. So x equals 0.29 recurring. I'm going to multiply by 100 because that would get me past the decimal that recurs. So 100x equals 29.29 recurring. Now those recurring chunks of numbers, they line up. They will cancel each other out when we take them away from each other, or one away from the other. 100x's take away 1x is 99x. 29 take away nothing is 29. X will then equal 29 over 99, like I said it would. And that fraction does not cancel down any further. Okay, now for the second one, I'm not going to go through that process, but you might have to. If you're going to get your marks on the question. I'm just going to write it as 306 over 999. We'll give you a little trick to decide whether your fraction simplifies. 306, those three digits add up to 9, right? And 999, those three digits add up to 27. And if your digits add up to multiples of 9, then it will be divisible by 9. So let's divide this number by 9. And if you do that, you get 34. Okay, bus stop method in your head. 999 divides to give you 111, and that is our final answer, 34 over 111. Sometimes you might be able to simplify a little bit further, but you can't in that instance there. Okay, now let's look at the last one, a little bit more involved, this one, because we've got a dot above one single number, but I'll show you what to do. It's a trickier one. It's one of these ones where you can do that step as well. So you've got x equals 0.16 recurring. 10x equals 1.6 recurring. Okay, there's our problem. That doesn't line up with that. So we're going to have to go past the point. So we're going to go 100 x equals 16.6 recurring. And then we're going to divide by, we're going to take away first of all. So that's 100 take away 10, which is 90x. 16 take away 1 is 15. And then x will equal 15 divided by 90. Get rid of the 90 from in front of it. You'll understand what that is when you've watched some algebra videos solving an equation. Very simple one-stepper. And then we can divide both of those numbers by 15. So that would give us 1 and that would give us 6. All right, and there's our answer. It's an exact fraction. There's our recurring decimal to our exact fraction. In number 2, we've got much the same things going on. I'm going to do the first one pretty quickly, because it's pretty much the same as the other question. So make that equal to that. 10x equals 0.2 recurring. 100x equals 2.2 recurring. They now line up. I'm going to get 90x equals 2. And then x equals 2 over 90, which would be, as a final answer, 1 over 45. Both divided by 2. Pretty quick, pretty simple. Get rid of that working for the next one. Now these are just a little bit more annoying, these sorts of questions, B and C. But if you've got this one here, we'll make it equal, as we always have to now, to x, or any letter, 0.765. recurring. Let's multiply by, so we go just in front of this recurring dot. Let's multiply by 100. So 100x equals 76.5 recurring. And then we'd have to go past it to get past the recurring decimal. So 1000x is equal to 765.5 recurring. They now line up. Happy days. All we got to do is 1000 take away 100, which is 900 and x's, equals 765 take away 76, which is annoying to do, but I'm going to do it. 765 take away 76. I'm going to do it in the column method. So 15 take away 6, because you nick one from there. 15 take away 6 is 9. Nick one from there, that becomes 6. 15 take away 7 is 8, and then 6, 689. So we've got 689 over 900 as our final answer, because we're dividing by 900. I kind of just missed that step there. So get rid of that. X equals this. All right, so 689 over 900. It doesn't simplify, that one. Get rid of all this. Let's do the last one. So the last one is just a tad more annoying again. You've got x equals 0.63 and then 75. Okay, so those two numbers, so it's going to be 75, 75, 75 forever. Going to multiply by 100. X, that equals 63.75. And that's the recurring numbers there. Then we're going to go past, so I'm going to get 10,000 x, because I've got to go 1, 2, 3, 4 places, jump over. So that's going to give us that. And that's going to be 6375.75 recurring. And then I'm going to do the 10,000 take away the 100, which gives us 900 and 9,900 x's. And then you're going to do this 6375 take away 63. Well, if you took away 63, you'd get to 72, and then 6312, and then we're going to go x equals 6312 over 9900. Let's just check to see if this one doesn't simplify. So that's 9, 10, 11, 12. So this one will actually simplify because it's the same sort of thing. We can divide. If the digits add up to 3 or multiples of 3, then it will divide by 3. All right, now this does divide by 3. Let's divide 6 by 3, we get 2, and then 3 by 3 we get 1, and then we go into there is 0, and then into the 12 is 4. Okay, and then we go over 9, 9 is going to be 3, 3, and then 0, 0. But again, look, even numbers, so that's going to simplify even further. We're going to go half of 2,104 is 1,052. And then half of 3,300, so that's going to be 150. And then that's going to be 1,500. So 1,650. Again, they're both even. That is going to be, if I half the 10, it's going to be 5. If I half the 52, that's 26. So 526. Half the 16, that's 8. And half the 50, that's 25. And I think we might well have got there in that long old process of simplifying a fraction down, because that doesn't add up to anything that we can divide by, and they're not both even. Lovely, brilliant. That is my final answer. I hope that is correct. Now, I told you it was a bit more awkward. Let's do number 3. Number 3, we've got to calculate the following. Give your answer as a fraction in its simplest form. Not sure why the division has moved over there. That should be in there. Right, I'm not going to remake this video. It's taken me 9.5 minutes already to talk to you about this, because it is some pretty tricky stuff. Calculate this, give your answer as a fraction in its simplest form. So we're going to go and do the whole process of making this a fraction, and then we're going to divide the fractions using our division of fractions method, which if you're not sure what to do with that, you're going to have to go and watch that video that I've made as well. So that is going to be x equals 0.07, 10x equals 0.7, I'll put the recurring dot above it as well, and then 100x equals 7.7 recurring. So that's going to be 90x equals 7, and then x equals 7 over 90. So that's our first fraction, 7 over 90. All right, just get rid of that. So we've got a bit of space to do some things, maybe with some division of fractions when we need to. Then we're going to do this one, so that's going to be, I'll do it over here, x equals 0.189 recurring. Then we're going to go 10, x is equals 1.89 recurring. Then we're going to go 100 again, and then sorry, we're going to go 1,000. We're going to go 1,000. 1, 2, 3, yeah. So that's going to be 189.89. Then we've got the recurring chunk of numbers lined up. That's going to give us a number of, so 1,000 take away 10 is 990. And then we are going to put the x on there, and we're going to do 189 take away 1 is 188, and that will give us x equals 188 over 990. Can we simplify that? Let's have a little look. So 8 plus 8 is 16 and 17. I don't think we can, but we can simplify it by halving, because they're both even numbers. So 100, that's half of 100 is 50, half of 88 is 44. Add them together, that's 94. 94 over, and then half of 990. Half of 900 is 450. Half of 90 is 45. So 495 is what that is. And then we have to do the division of division calculation here, which I can't be faffed to do, but I'm gonna have to. Right? It's just so much. I shouldn't have made this question so difficult, should I? Why did I do that to myself? Hey, what did I do that for? Anyway, we've got that. Let's put that up there. 94 over 495 divided by. Right, division of fractions. We have got to keep, change, flip. So keep 7 over 90 multiplied by 495 over 94. And then we're going to see if we can cross cancel those fractions. We can divide both of those numbers by 5. If we divide that by 5, we definitely get 18. If we divide that by 5, we get 90 something. How many have I got left over? If I've divided that there, I've got 4 left over. 99. So we get 99 if we divide by 5. Oh yeah, of course we do. Because yeah. And then we could do 7 times by 99. Because I don't think we've got a number there that we can cross cancel. So 7 multiplies by 99 to make whatever. Let's do it in this. That is 9 times 7, 63. And 9 times 7, 63. So 3, 9, and then 6. So 6, 9, 3 over, and I'm not going to bother simplifying this at the end, you can sort it out yourselves if it does. 18 times by 94, let's do that there. And you probably wouldn't get a question like this in an exam paper, but I've done it to myself. 72, 32, 9 and 4, 2, 5, 9, 9 and 7 is 16, and then that's 1692. I think that's the answer. I hope it is. If it isn't, I'm going to remake the video and then I'm going to go and cry quietly in a corner. Please do like the video because this one took me ages. Subscribe to the channel, become a bear cub if you can. That's the end of the number stuff. I will be back for algebra, but before I do make any algebra ones, I'm going to make sure I link in all the resources that you can use for this throughout this process, just to improve your own skills after watching the videos. That's the best thing you can do, is practice after you've watched something. Keep going. I like the quote that hard work beats talent if talent doesn't work hard. All right, so work hard at maths and you will improve. Right, it will happen. It does take a bit of time. It's not the easiest subject to learn, but when you start getting stuff right, it can be very, very enjoyable for you. All right, so please don't watch too many of my videos all at once, because you will get bored of me. You get bored of my voice. I'm sure you probably already have at the end of this one. I've got bored of my own voice. I've got to watch all my videos back. Don't envy myself. I'm sure you don't envy me even. But there you go. That's it. Number stuff done. Brilliant. Enjoy and be lovely to one another. Bye bye.